We think of electricity as a strictly modern invention, but a small clay pot dug out of the dirt might push that timeline back 2,000 years. In 1936, workers were digging a new railway line near Baghdad when they unearthed an ancient Parthian settlement. Among the scattered bones and broken pottery, a German archaeologist named Wilhelm König spotted something unusual. Inside this 200 BC clay jar was a rolled copper cylinder. Suspended down its middle was a rusted iron rod. Thick asphalt plugs at the top and bottom sealed the container, which crucially kept the iron and copper from ever touching. This specific arrangement of isolated, dissimilar metals matches the engineering requirements of a modern galvanic cell. Electrochemistry relies on a sequence of reactions. Filling that sealed copper tube with an ancient weak acid, like wine or vinegar, causes the iron and copper to react. Electrons flow from the more reactive iron to the less reactive copper, generating an electric current. Recent analysis suggests the device's complexity goes even further. The ancient makers used tin solder on the copper vessel and placed it inside a porous, unglazed clay jar, which creates the conditions for a second type of power source. When this tin-air system is combined with the internal reaction, modern reconstructions of the artifact produce over 1.4 volts of electricity. Demonstrating a 1.4 volt potential proves the device is physically capable of delivering power, turning the mystery away from its internal physics and toward the actual motivations of its builders. That voltage adds up. Engineers and researchers, including the team at MythBusters, have built replicas and wired them together in a series, successfully generating around 4 volts of power. With that much current, you could run practical applications. Wilhelm König's own theory was electroplating. By running the battery's current through a chemical bath, an ancient jeweler could force dissolved gold particles to bond onto a piece of silver. Other researchers looked to early medicine. Greek and Roman physicians were known to press live electric rays against a patient's forehead to treat severe headaches. A battery could have offered a more consistent way to deliver a localized numbing shock. Then there is the psychological application. Ancient temple priests often relied on hidden mechanics to awe their followers. Wiring a battery to a metal idol would give anyone who touched it a sharp tingle, an invisible sensation interpreted as the touch of a god. While these theories are scientifically viable, they lack any supporting documentary evidence or ancient diagrams, providing a wide opening for archaeological skepticism. Most mainstream archaeologists point to a missing link. No ancient texts mention electricity, and no conductive metal wires have ever been recovered alongside the jars. There's also a practical engineering problem. The thick asphalt seal entirely encases the top of the iron rod and plugs the copper tube. If meant to be a reusable battery, getting inside to top up the acidic liquid would be extremely difficult. Because of this, the conservative explanation suggests the jars were simply protective containers for sacred scrolls. In this reading, the copper and iron acted as a rigid structural core meant to keep the papyrus from rotting in the ground. But the scroll theory faces its own evidence gap. No traces of organic paper fibers were ever found inside the vessels, and the specific pitting on the metal indicates exposure to an acidic liquid, not decaying parchment. This leaves the artifact in a frustrating purgatory. It is too precisely engineered to ignore as a simple container, but too isolated in history to definitively prove as a tool. We may never get to physically test the original artifact again. In April of 2003, during the chaos surrounding the invasion of Iraq, the National Museum in Baghdad was looted. The original Baghdad Battery was stolen and remains missing. Without the object, we are left with the core dilemma of experimental archaeology, distinguishing between a technology that can work and one that was intended to work. To address this, a 2024 simulation modeled the Baghdad Battery's geometry against thousands of random component configurations using materials available in the Parthian era, such as various cylinder-to-rod ratios and seal positions. The simulation revealed that the specific dimensions of the copper cylinder and the depth of the iron rod were nearly optimal for current production. These choices align so closely with peak electrochemical efficiency that they suggest a design refined through empirical testing rather than random assembly. Whether the Parthians understood the theory of electron flow or simply observed a useful effect, ultimately the Baghdad Battery remains a truly functional anomaly, a piece of optimized electrical engineering from over 2,000 years ago.